Okay, so today what we're looking at with 4.2 is describing variability. So this is really describing spread. So we've talked about center yesterday, we talked about shape in chapter 3, so now we're going to talk about spread. So knowing the shape and the center of a data set gives us some understanding of its distribution. But we do not know the whole story until we investigate the spread. Or they use it interchangeably. You'll see they'll use variability a lot. They mean the same thing. This is just a fancier word. So obviously if you have a data set, you can have low variability, where like here the mean is, I don't know, 75, and everything's kind of close together. Or you can have high variability, where everything is super spread out, but your average is still 75. So we need to talk about spread because it makes a big difference. Obviously the one that we've been using so far has just been the range. It's the max minus the min. Just be careful when you're talking about range. Range is one number, not two. Some of you on the quiz put it as two numbers. Just make sure it's one. Although it's simple to calculate, the range has a big weakness. It is not a resistant measure. It only looks at the two most extreme values. So that's kind of hard, especially if you have an outlier. Instead of only using two data points, it's better to measure the spread, consider the entire data set. Excuse me. One way to do this is to estimate the average deviation from the mean. So this is called the standard deviation. Okay. Here's the formula. S is big square root sign. So it's parentheses x1 minus x bar squared plus x2 minus x bar squared plus dot 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 plus xi minus x bar squared all over n minus 1. Or it's the sum of each x value minus x bar squared over n minus 1. Now, what this means, this is the size of a typical deviation from the mean. Now, you do not have to memorize this formula. So you will get a formula sheet, and we're going to kind of go through it step by step, but here's the one that I have from this year. So we talked about the mean yesterday. So the formula is on there. Here's the standard deviation formula. So again, it's the sum of each x minus x bar squared over n minus 1. So right there, right at the top, are two formulas. Now, you can write in what I have here, the mean and the standard deviation. For the AP test, obviously, none of these things that I wrote on it will be on there, but for now, you can write it on yours if you want. So, find and interpret the standard deviation for these numbers. So, I'm going to do us a favor. I'm going to tell you that x bar is 7. So, that's going to help us. So, it's kind of a pain. So, S is the square root of 1 minus 7 squared plus 13 minus 7 squared plus 11 minus 7 squared, 1 minus 7 squared, 5 minus 7 squared, 9 minus 7 squared, 6 minus 7 squared, 5 minus 7 squared, 8 minus 7 squared, 11 minus 7 squared, all over 10 minus 1. So, I'm going to kind of do this in my head a little bit. So I have 36, 16, 36, 4, 4, 1, 4, 1, 16. So it would be the square root of 154 divided by 9. So it's the square root of 17.11. So it's 4.137. So what does this mean? 4.137 represents how far a typical data point is from the mean, which here is 7. So the closer and closer, the smaller the standard deviation, the smaller your spread. The higher standard deviation, the higher your spread. Okay, so it represents a typical deviation from your mean value. Now notice we were squaring everything, and the reason that we square everything is because obviously in some of these you'll have like a negative, and then a positive, and then a negative. So it just alleviates the negative. So if we square it, everything becomes positive. So if we had the entire population, we would use, this is sigma, lowercase sigma, to denote the population standard deviation, which describes how spread out all the values are from the true population mean, which remember we talked about yesterday, it's mu. In the calculation, we would use mu instead of x bar in the numerator and n instead of n minus 1. Since we rarely study the entire population, we usually estimate the population standard deviation with the sample, which is S. So always assume data sets are samples unless you're otherwise told. Now, one thing that we're going to talk about later that I'm not going to get totally into, but the square of the sample standard deviation is called the sample variance. It will come in handy later. It's just S squared. So like my variance in that, so like S squared in that previous example was 17.11. So that gives you your variance. We'll talk about it. It'll ask you like a couple of homework questions. What's the variance? You just take the standard deviation and square it. Okay, what if the last value in the data set was 41 instead of 11? Can we calculate the new standard deviation? So yeah, we'd have to go through. It would have a new mean. I'll show you the new mean's 10. So we'd have to do like 1 minus 10 squared plus 13 minus 10 squared plus whatever plus, and then 41 minus 10 squared all over 10 minus 1. Now there is a way to do standard deviation in the calculator because we don't want to do it all, every time. So what you do is you put, I'm going to put everything in list 2 because I'm going to need list 1 again for another example. So what you're going to do, maybe I'll just tell you. No. Let's do it. So you put this in list 2. I'm going to do 1, 13, 11, 1, 5, 9, 6, 5, 8, and then 41. So I'm going to go to my one variable stats again. So calc, one variable stats. I'm going to do list 2. And then to calculate it, so here's our new mean, which I said was 10. Now here's S and sigma. We're going to use S. So again, assume it's a population. It's a sample. So I would just say S equals 11.56. Now on your quizzes and your tests, I need to see the formula. But I'm okay with just like this. You put the first couple ones in and then give me the answer. But I do need to see the formula. So if I tell you to show work, this is what I want. Okay. Can S be 0? Yes. If the data set was all the same number. So if I had every person get the same quiz grade, my standard deviation would be 0. I'd have no spread. Can S be negative? Well, I kind of gave you a sneak peek of that. Can S be negative? No. Think of it as a distance. So it's a distance. You can be a standard deviation below the mean, but S is always positive. That's because we were taking, like I said, the square of all the numbers. So square roots, you may have learned, can have a positive or a negative, but the actual answer is always positive. So the other way to talk about spread, if you don't want to do standard deviation, especially if you have, like, we're going to get to box plots tomorrow, is the interquartile range, or the IQR for short. It's the middle 50% of the data. So the IQR is Q3 minus Q1. So Q1 is the first quartile, the point which divides the lowest 25% from the upper 25%. Q3 is the third quartile, the point that divides the lowest 75 from the upper 25. The median is always your second quartile, although it's very rarely referred to that way. So in order to find Q1 and Q3, you put the data in order, find the median. Q1 is the median of the lower numbers, Q3 is the median of the upper numbers. So here's our weights from before. So again, we have n equals 30. So if I want to find the median, I'm going to do 31 divided by 2. So the median is between the 15th and the 16th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's in between 141 and 144. So I'm going to take the average. So I get 142.5. So the median's right here. Now for Q1, I'm looking with just like, I think about it as the median of the lower quartile. So there's 15 numbers in the lower quartile. So if I do 15 plus 1 divided by 2, that means it's the 8th number. So 1, 2, 3, 4, 5, 6, 7, 8. So Q1 is 128. Q3, again, is the 8th number from the median. So 1, 2, 3, 4, 5, 6, 7, 8. So it's 162. So then the IQR is 162 minus 128, so 34. Okay? So if we were to change the 225 to 525, would the IQR change? No. Does the range change? Yes. So which is resistant? The IQR. So there's basically like 3 ways that you can talk about spread. So we're doing our socks. You basically have 3 options. You can talk about the range, but again, it's not resistant. You can talk about the standard deviation, which comes in handy if you have a small amount of things, or you can talk about the IQR. Okay, so you have 3 options here. So just like with center, you had mean and median, spread, you have 3 options. This was an even number distribution. If there was an odd number, the median is one of the observations in the set, and then you don't consider it part of the upper or the lower half. So if you had like 7 numbers, okay, 4 is your median, you take him out of consideration for Q1 and Q3. So Q1 here would be 2, Q3 here would be 6. So like in that upper one, this example, I had 30 numbers, so I didn't care, I had 15, 15. When you have an odd number, you take out the median, so you still have 3 and 3. That's it.